Okay, good morning to all of you. Devi is okay. Thank you, Saksham. Okay, let us start today's class. So, in the last class, we studied about reliability of power system. So, in that one, we are seeing the two-state model as an example, and we got the two parameters which is related to the probability, that is known as availability and unavailability. These are the two things which I have given it and we have discussed in the last class. Okay, fine. Today let us discuss about optimal generation scheduling. So this is the optimal generation scheduling. We are going to discuss it in today's class. So what is this optimum generation scheduling? Already we have seen case 1, optimum generation scheduling. Case 1 we have seen, already we have studied. That means neglecting losses, neglecting transmission losses. So we have seen what optimal generation scheduling. So what is the criteria for optimal dispatch? Neglecting transmission losses. The criteria for optimal dispatch, neglecting transmission losses, is that the incremental fuel cost of all the units are equal. The incremental fuel cost of all the units are equal. That is dC1 by dPg1 is equal to dC2 by dPg2 is equal to etc. That is equal to lambda, is known as your incremental fuel cost for all the units will be same. That is the optimal dispatch criteria, neglecting transmission losses. So this is what we have studied. Now let us see any system we cannot neglect the losses. That too power system we cannot neglect the transmission losses. So we have to consider this transmission losses. So whatever the optimal dispatch criteria we got neglecting losses, that is known as coordination equation. What is the coordination equation? dC1 by dPg1 is equal to dC2 by dPg2 etc. is equal to etc. is equal to lambda. This is your coordination equation. We got it. That is nothing but your optimal dispatch criteria. Okay. Now let us see optimal generation scheduling considering losses. This is the thing. Same analysis, but only thing is we are going to consider the transmission analysis. So if the transmission losses are neglected, so what we have seen, the optimal dispatch can be optimally divided among the various generating plants using the equal incremental cost criteria. This is what I said it just now. Understood? Suppose the losses are neglected. If two units or two plants are there, then how the load is distributed equally. These two plants will be sharing it equally or divided among the various generating station using the equal incremental cost criteria. Understood? So this is the criteria by neglecting the transmission losses. This we already studied. Now if all the units are same plant, that means if you take a Raichur thermal station, there are 8 units. So all the units are at same plant. Then only economic dispatch is determined by neglecting losses. Understood? So that means Raichur thermal power station, we are having 8 units which are situated at the same location. Then you can do the optimal dispatch or economic dispatch by neglecting losses because you are not transmitting over any transmission line, isn't it? So you can find out the economic dispatch neglecting losses. In that cases, in order to find the optimal dispatch or economic operation among the various units which are situated at the same plant, so you can neglect the losses because you are not transmitting the power. Hope you understood this one. Okay, some of you Maybe thinking, what is this Raichur thermal power station, isn't it? So there is a place called in Karnataka Raichur. So there is a thermal power station is there in the Raichur. So that's why I'm using a word frequently, RTPS. RTPS means Raichur Thermal Power Station. So please, so because I know regarding Karnataka state, so that's why I'm using this example. So others, please, RTPS means it is a Raichur is a place where thermal power station is situated. So it may be around maybe 450 500 kilometers approximately from Bangalore. So there are other thermal stations are also existing in Karnataka, but for your explanation, I am taking only one example as a thermal station. Why I am not taking a hydro power plant? Because hardly there is no may operation cost. Because what is the fuel we are using it? Water. So obviously it is apparently free. Coming back to nuclear power stations, why you are not considering economic dispatch? Because nuclear power plants operate on base loads. There is no variation in the loads. One nuclear power station, if you start, the load remains constant on that station. So that's why we are not considering. So that's why we have to focus only on the thermal plants. So I think it is clear for other students from Karnataka. Now, if plants are different locations, then transmission losses to be considered. Now, you see, this is the thing. If the plants are at different locations, now if you take in Karnataka, there is Raichur, there is a plant, and near Ballari, there is a plant near Kudithini, and also Jindal also they are having it one thermal station. So and also other locations, so a small units we are having it. So if the plants are different locations, then this generated power has to be transmitted over a transmission line. So you know that you are studied in transmission and distribution. Whenever is power is transmitted over a transmission line, obviously a small value of resistance will be there in the transmission line. So therefore transmission losses will occur. Understood? So this is the thing. If the units, all the units are located at same plant, you neglect transmission losses, you find out economic dispatch. If plants are at different locations, then you have to transmit the power over a transmission line, then transmission losses to be considered. So these are the two things you have to remember in your mind. Why I am saying it? Because sometimes they may not ask you to whether to neglect losses or consider losses. So looking into the situation, if an example has been given saying that all the units are at same plant, obtain the optimal dispatch. So that means same plant means all the units. So no power transfer is taking place. So no transmission loss. So therefore, what is the coordination equation or optimal dispatch criteria with neglecting losses? All incremental fuel cost will be same for all the plants. If plants are at different locations, obviously we have to consider the transmission losses. Now, these transmission losses actually may vary from 5 to 5% of the total load. So this is generally we say 5 to 15% of the total load, but generally practically if you see it, it will be almost up to 25 to 30% in India. So these losses will be there 25 to 30%. So generally considering, because we are not considering the theft, power theft, etc. and all those things. So that's why we are saying it 5 to 15%. If you take overall thing, including everything, then it may be around 25 to 30 or sometimes it is 35% also. So this is the transmission losses. So if total load, suppose you need a total load demand, total load is 100 megawatt. On the generator side, generation side, if you are generating 100 megawatt only, if you are generating 100 megawatt, the load demand is 100 megawatt and it is not sufficient. Why? Because you have to transmit that power over a transmission line. Over a transmission line. So whenever you are transferring this power from generating station to the load point over a transmission line, transmission loss will occur. Understood? So therefore, what is the generation you have to consider at the generating station? So what is the generation to be to meet the load demand of 100 megawatt? So what is the generation on generator side? Anyone? What is the generation to be? Load is 100 megawatt. You assume it, and you assume that there will be a loss of 10 megawatt. Transmission loss is 10 megawatt. So then what will be the generation to be? So generation to be, obviously, what is the generation? Yeah, I'm getting answers from Saksham location. So 110 megawatt, obviously. So that means what? So the generation has to take care of the losses also. Generation has to take care of the losses also. That means these losses also may be treated as a load. Indirectly, it's not directly, but it is indirectly. You can consider these losses as a load. So 100 megawatt is the actual load demand, and the losses is 10 megawatts. So 100 plus 10 is 110. So 110 megawatts, isn't it? 110 megawatts is the total load. So indirectly, you can consider these losses also as a load. So that generation is equal to total load plus losses. Is it clear? So this is what we have to consider it. Now you see, same thing I have explained it. Therefore, it is essential to account for losses while developing an economic load dispatch policy. Hope with this example it is clear how we have to consider. So losses also becomes a part of your load. Indirectly I said. You can consider this losses also as a part of load. Now we investigate how the load should be shared among various plants when line losses are considered. So in this section, case 2, I can say this one. Case 1, neglecting transmission losses. Case 2, we will say considering transmission losses. Now here we investigate how the load to be shared among various plants when line losses are considered. When line losses are considered, how the load is shared. So this is nothing but again optimal generation scheduling. We have to do it. So what will be the objective function in optimal dispatch or economic dispatch is to minimize the overall cost of generation. This you are aware of it, isn't it? The objective is to minimize the overall cost of generation. Already in case 1, so we have defined the objective function. So what is the objective function? We have defined it here. So minimize, you write it minimize here, MIN is equal to, so this one. So what is CI of PGI is nothing but your cost of generating PGI, cost of generating PG at ith unit or ith plant. Understood? So like that you have to, what is the total generation? You have to add all the costs of all the generation. So you will get the total cost of generation. So this total cost of generation you have to minimize. This is the objective function. We have seen either in case 1 or case 2, it is same thing. Okay, now what are the constraints? Constraints are there. So whenever you want to achieve some goal, you have to satisfy some constraints, some conditions you have to satisfy, isn't it? So in order to take up the main exam, so the minimum internal marks, you have to score it. So that is a constraint, isn't it? It should be greater than or equal to, your internal marks to be greater than or equal to, so X. So then only you are eligible to take your examination. So some constraints is there. So in order to achieve this objective function, equation 1, so constraint, what are the constraints we have considered? We have considered the equality constraint. Equality constraint. In case 1 means neglecting losses. What we have taken in case 1? So total generation PGI is equal to total load, isn't it? Total load. But here we are considering losses also. So the equality constraints will become total generation is equal to load plus the loss PL. This is the extra component losses we are getting it. Okay. So this is the equality constraint. Now what we have done in case 1? So we have augmented this equality constraint into this objective function. We have to augment this equality constraint into this objective function. So how to augment the constraint into the objective function? Using Lagrangian multiplier method. Using Lagrangian multiplier, we have augmented the constraint into the objective function. Same thing we are also applying here. Here also we are going to apply. Now next step is augment this equality constraint into this objective function using your Lagrangian multiplier. And obviously, you know what is PGI generation at ith plant, PD is total load demand, PL is total line losses, K is total number of generators. Understood? K is total number of generators. I think in earlier case we have taken NG, number of generators. But here we are taking, instead of NG, we are taking K. Any parameter you can take it. But correspondingly you define it, what is it. So as I said, this to be augmented in objective function. So how to augment this one? Before augmenting it, so let us put this one in a equality form. This one, put it in a equality form. PD minus plus PL, I am taking it to all LHS and equating that one to 0. Call that one as equation 3. Now you augment equation 3 into equation 1 using Lagrangian multiplier. Okay, let us see how to augment this one. So using Lagrangian, already I told this one. So now you see this is a Lagrangian is equal to, so total cost minus lambda of the constraint, equality constraint. This is how you can augment it. Understood? So how you are going to augment? Using Lagrangian multiplier. So Lagrangian is equal to this total minus lambda of the whole constraint. This is what the same thing we have done it in case 1 also, but there we didn't have PL. So only we had only this one. Okay, fine. That's what we are doing it here. You see here, this one minus lambda of this one. So actually here it is 0 is not there. So just this is what we have to do it. Summation of Pji minus Pd minus PL. This 0 is not there actually because I have taken the whole constraint. So it is not there. Let me correct it here only. Okay. Now this is the equation. This is how we have augmented the equality constraint into the objective function. Clear? Now after this step, what we have done in case 1, same procedure here also we have to follow. I think you may not be remembering those things. So let us see this one. First you assume power factor at each load bus remains constant. So first thing is assume the power factor of load at each bus is same, that is remains constant. Under this assumption, so the system losses PL can be shown as a function of generation at each plant. Is it clear? Assuming the power factor of a load at each bus is constant, then this system loss PL is represented as a function of active power generation. Active power generation is PG. Active power generation PG at each plant. And how it is denoted? That is PL is a function of active power generation. Understood? PL is represented as PL of PJ, means it is a function of active power generation. So here it is PGI. There may be K number of generating plants. So in such cases, this can be further. So PGI is only the control variable. Here you can control only PGI, isn't it? So that is only the one control variable we are having it. So again, this is represented by PG1, PG2, PG3, etc. PGK. What is K? There are K number of generating stations. Is it clear? So this is how we are going to represent the transmission loss PL as a function of its active power generation at each plant. At each plant. That's why we have represented PG1, PG2, etc. PGK. Clear? So augment the equality constraint to objective function. Represent the transmission loss PL as a function of active power generation at each plant. Then the minimum of this constraint function, that means the minimum of this constraint function is found by taking partial derivative of the function with respect to PGI and equating it to 0. Same technique, that is same thing we have applied in case 1 also. Case 1 also, after augmenting, what you have taken? We have taken the partial derivative of this Lagrangian equation with respect to PGI and equating to 0. Then you are going to get the minimum value. Understood? So we have to take dou L to, so dou Lagrangian multiplied to dou PGI is equal to 0. Take the derivative of this equation and equate it to 0. Okay. So for your reference, again I represented that equation. Equation 5. Okay. Okay. So for optimum real dispatch, for optimal real dispatch, so dou L to dou PGI is equal to this one. You are done in case 1, already I have explained. So this becomes dCi by dPGI, dCi by dPGI when you take derivative of that one, because when I is equal to 1, it is Pg1, C1. So with respect to Pg1, so if you are taking it is only 1, because for each unit we are taking partial derivative, isn't it? So that's why it will become only 1 dCi by dPGI minus lambda. Okay. So again, this is summation PGI. When I is equal to 1, this becomes Pg1 only, isn't it? So you are with respect to a partial derivative with respect to Pg1, so becomes 1. PD, load demand, is a constant, 0. Understood? Minus PL. What is PL? Transmission losses. Transmission losses, how you are representing? Transmission losses, how you are represented, is a function of the active power generation. Is a function of active power generation. So when active power generation changes, this transmission losses also changes. That means PL is not a constant. So PL is a variable. So we cannot consider this one as a constant. However, load demand is constant. So load losses will vary depending on the generation, because it is a function of active power generation. So how we are going to take partial derivative? Dou PL to dou PGI equated to 0. Taking partial derivative of the whole equation and equate it to 0. Clear? So where I is equal to 1, 2, 3, K. That means K is the number of generating stations or plants. Hope you understood this one. Taking Lagrangian Lagrangian multiplier, then partial derivative of this equation 5 as resulted in this form. Understood. So now from this part we have equated to 0. So we have to get it for value for lambda. So how we are going to get the lambda? Take this whole term onto the RHS side, solve for lambda. That is, lambda is your incremental fuel cost. So therefore dCi by dPGI, I am taking this term onto RHS side. I have taken it. Okay. Then what you have to do? I want lambda is equal to dCi by dPG by divided by 1 minus dou PL to dou PGI. This is equation 6. Hope you understood this one, how we got this equation. Is it clear? Now this one we got it. From this one, I am going to write lambda is equal to dCi by dPGI multiplied with Li. Just some multiplication factor, I have taken it here, it has a Li. The equation 6 can also be represented as lambda is equal to dCi by dPg into Li. So what is Li here? What is Li? What is Li is nothing but your this term 1 over 1 minus dou PL by dou PGI. Understood? This Li is nothing but 1 divided by this one. So that I am going to represent it. I will show it to you in the next slide. Equation 7 implies that minimum fuel cost is obtained when incremental fuel cost of each plant is multiplied by its penalty factor is same for all the plants. This is the criteria for optimal dispatch. That means, you see, what implies minimum fuel cost is obtained when this is your incremental fuel cost is multiplied by Li. Li is known as penalty factor. Li is known as your penalty factor. So what is Li? 1 divided by 1 minus dou PL to dou PGI. Clear? So Li is known as penalty factor. So what is the criteria for optimal dispatch when transmission losses are considered? In order to get minimum fuel cost, the incremental fuel cost must be of each plant is multiplied by a penalty factor Li is same for all the plants. Whereas in case 1, when losses are neglected, how you got dci by dpgi is equal to lambda. This penalty factor was not there, isn't it? Now losses you have considered, so you are getting the incremental fuel cost is multiplied by a penalty factor remains the same for all the plants. That means dc1 by dpg1 into L1 is equal to dc2 by dpg2 into L2 is equal to dc3 by dpg3 into L3, etc. That means all the incremental fuel cost multiplied by penalty factor will remain same for all the plants. This is equation 7. Understood? So now coming back to this one, again 6 I have written it for your reference. So I am going to replace it here. You see, is known as penalty factor. I have explained it, isn't it? What is Li from this equation? 1 divided by 1 minus dou PL to dou PGI. That is your Li we have replaced. That you call it as 8 is known as your penalty factor. Now the partial derivative dou PL to dou PGI is referred to as an incremental transmission loss. You see here, this one, the partial derivative dou PL to dou PGI. What is this dou PL to dou PGI? Is nothing but your incremental transmission loss. Understood? What is DCI by DPGI? It is incremental fuel cost. Incremental fuel cost. That means if you are increasing the generation by 1 unit, what is the change in cost? So that is known as your incremental fuel cost. Now what is dou PL to dou PGI is your incremental transmission losses. That means if the generation, if you are increasing by 1 unit, what is the corresponding losses that is going to occur? So this is known as incremental transmission loss, which is indicated by ITL, incremental transmission loss. ITL of I means incremental transmission loss at ith unit or ith generating associated with ith generating plant. Is it clear? The difference between dou PL to dou PGI and DCI by DPGI. Now the Lagrangian multiplier lambda, this lambda is in rupees. What is the unit? We have represented incremental fuel cost is rupees per megawatt hour. When cost is represented in rupees per hour, because sometimes what they will mention it dollars per hour, isn't it? So in such cases it is dollars per megawatt hour. Like that it will change. That's why we are telling this Lagrangian multiplier lambda is nothing but your is equal to DCI by DPGI. We have seen it is nothing but your incremental fuel cost. The unit will be rupees per megawatt hour if the cost is represented in rupees per hour. Now here you see lambda is equal to this one, we got it. So again we are writing it this one, this equation. How we got this equation 9 here you see. Now here you see 1 minus dou PL to dou PGI, isn't it? So what is this one? 1 minus this one 1 minus dou PL to dou PGI is your incremental transmission loss. So 1 minus ITLI. This part I am replacing it as 1 minus ITLI. So into cross multiply lambda into this term. So what is that one? Lambda into 1 minus this term is your ITL, incremental transmission loss. That's what I have written it is equal to DCI by DPGI. What is DCI by DPGI? Is nothing but incremental fuel cost. Incremental fuel cost. In case 1, incremental fuel cost is equal to lambda. But here it is not equal to lambda. It is multiplied by another factor here. Is it clear? From this equation, this dou PL to dou PGI, I am replacing it with ITLI, cross multiply lambda into 1 minus ITLI is equal to DCI by DPGI. We are getting it. This DCI by DPG is nothing but incremental fuel cost, which is indicated by ICI at ith plant, is equal to lambda of 1 minus ITLI. You should know what is ITL. Equation is dou PL to dou PGI. Understood? What is IC, incremental fuel cost? Is nothing but your DCI by DPGI. This equation 9 is known as exact coordination equation. This is known as your exact coordination equation. So in the question they may ask, obtain the exact coordination equation. Most of the students, they will commit the mistake. Obtain the exact coordination equation. If they ask this question, so don't derive dci by dpgi is equal to lambda. That is dc1 by dpgi1 is equal to dc2 by dpg2 is equal to etc. dcn by dpgn. N generators are there, is equal to lambda. This is the coordination equation when losses are neglected. Most of the student, whenever the question is asked like this exact coordination equation, obtain the exact coordination equation, they will derive that equation. Understood? That is wrong. So read the question what they have asked. If they ask exact coordination equation, then this is what you have to derive, equation 9. You have to get it. Remember this point, because even though if we say several times to the students, finally they will commit this type of mistake in the test and examination. They will derive the case 1 formula when they ask exact coordination. When they will ask only coordination equation, okay, case 1 you can consider. If they ask exact, then case 2, that is this equation 9, you have to get it. Hope you understood this one. So please remember these things. So this is your optimal generation scheduling considering the transmission losses, and this is how we are going to get the exact coordination equation. Clear? So any doubts you are having it till this point? Any doubts? Hope it is understood you for you. Okay, any something from doubt? Lambda is constant for all PGI. No, generation, see lambda will change. Understood? Lambda is a Lagrangian multiplier. Here in this case, it is different. Whereas in the case 1, it is all equal to lambda. That's what we have seen it, isn't it? So now here in this case, depending on your generation, it will change lambda value. Any other questions if you have? Okay, I think, hope you don't have any question. I understand that you don't have any question. So I think somebody has asked to revise the portions which covered under module 1 and module 2. So revision of the module 1 and module 2, is it required? Is it required? Module 1 and module 2, revision of module 1 and module 2, is it required? I'm asking everyone. Those are now the strength is here 46 is there. Is it required? I will do it. I am ready to do it. No problem, not an issue. But I want to know how many students are interested to have revision of your module 1 and module 2. That just put it in a chat box. Okay. Saksham, we will solve one numerical problem in the next class. Okay. Then you will come to know that one. It will clarify your lambda. End of the semester you need. Not now. Okay. See, this lambda value depends on whether you are dealing it with case 1 or case 2. That means with transmission loss or without transmission losses. You will see that one when we consider one numerical problem. We'll get a clear idea about that one. Okay. So revision at the end of the semester, they're asking. So one thing I will tell you, I am ready to revise the module 1 and module 2. But only the thing is, let me complete this module 3 first. I will complete this module 3. It will take maybe within this week. I may complete, hoping to complete this module 3. Then I will start doing revision of module 1 and 2 before the first test. Before the first test, just I will revise the module 1 and module 2. Then we will see. And which topics you need revision, because to cover entire module 1 and module 2, you know that I have taken almost 24 hours. 24 hours of class. I am saying it. To complete module 1 and module 2. Again to revise the entire thing, again I need some classes, isn't it? So some important topics, if you can tell which topics you need, then I can do revision on those things. You discuss among yourself, so which topics you need revision, etc. Or do you need the entire module 1 and 2? When you need, so all these clarifications are required for me. I am ready to do it. From my side, I don't have any problem. I am ready to do it. So only thing is I need clarification, because I cannot go with one or two students' opinion. Understood. So test is still not yet announced, because this week we will wait for VTU guidelines. This is what principal said. Anyway, it will be informed at least 1 week before. At least 1 week before it will be informed to you. Suddenly they will not announce. Minimum time will be given to you. At least 1 week will be there. So don't worry about that one. So because the colleges are waiting for VTU directions to conduct these tests. If they are calling the students physically, then they are planning to conduct physically. Otherwise, they will go for online test only. So doing revision of the module 1 and module 2, please discuss among yourself. I think you may be having your personal groups, etc. Discuss, and you can highlight the topics which I need to cover, or should I cover the entire module 1 and 2 just on a fast track basis. So then I am ready to do it. So I need clarification from majority of the students, not from one or two. Understood. If you are taking the suggestion from one or two students, if I am doing it, then the others may not like it. And vice versa is also true. So that's why I want opinion, clear opinion on this instruction, that is revision of module 1 and module 2. Anything else? So I will start. So time is, what is the time left out? 12:15. Okay. Okay, another topic. If I want to start, I need time. So I'll start it. So just you brush up this exact coordination equation means considering the losses. So then we will see that later. Okay. Okay, I will end the class then. So within this week, please discuss among yourself. Give me the clarification regarding the revision. I am ready to do it. From my side, I don't have any objection. Okay then. Thank you, one and all. Take care. Bye.